So I've been developing web applications for over 10 years now. And some of the times you get to build a brand new application from scratch, and that's great. We all love to do that. But a lot of the time it's migrating a legacy application over to the new hot tech stack of the day. Now, 10 years ago, whenever I first started, those were servlet applications typically. Maybe a little bit of JavaScript here or there for some interactivity. And then jQuery came out, and that was a game changer. It opened up full-featured web applications entirely in JavaScript. So a lot of my early projects were migrating servlet applications over to jQuery. Well, nowadays, that might be migrating a jQuery application over to something new, like Angular. So that's what I'm going to talk about today. And so if you leave here with nothing else today, I want you to know that you too can migrate a legacy, unmaintainable application to a more stable, modern framework like AngularJS. And better yet, you can do that with the same team that produced that legacy, unmaintainable application in the first place. So first, we're going to go over what it means to have a legacy application. How do things get to the point that you need to change things? And then we're going to talk about how you set your team up for success, regardless of whatever tech stack you choose. And then finally, we're going to talk about how to implement the technology the right way, using some concrete examples that my team did on an Angular migration of a jQuery project. So first, what is a legacy application? Well, it could be an application that's been cobbled together over the years with just lots of features slapped together with no thought as to what it'll end up with. Something like that. Where they may have started with one or two bumper stickers, but over time, this just became a mess. And there's just no way to get rid of this except for starting over. Or it could be something that's a really powerful application, like the application I'm currently working on. It's been in development for years and years. It's very, very powerful, but it's like this. It's hard to maintain. There's just wires everywhere. This is actually a supercomputer. It's the Cray 1 supercomputer from back in the 70s. Super powerful machine, but each one of those wires has to be cut to a very specific length so that things end up in the same place at the right time. There's probably one or two guys in the world who know how to fix this. So that's a problem because it's very hard to maintain that. So why is that a problem? Well, first, it ends up in higher costs. Because, like I said, there's only a couple people who know how to maintain this, plus it just takes longer and longer each time. Or it could be slower to release to production. It takes longer to do things whenever you have a really convoluted code base. And it produces low morale on the team. Nobody likes to work on a really bad code base. I mean, I don't like it. I'm sure you guys don't either. So how do things get to this point? Well, here's an example. Let's say a simple JavaScript function. Don't worry if you don't know JavaScript. All this does is when you click these two buttons, it hides and shows something. Very simple. So next sprint, our project manager wants to add some animation, to make it look nice. And then we're gonna add some classes for CSS styling. And then we're gonna check the target's current state to see whether we want to hide or show it. And now we're gonna do some other stuff based on user roles. No big deal so far. But month after month after month, we keep doing this, and then a year later, we end up with something like this. I can't tell what this does anymore. It's hard to follow. Well, I walked into a project that's been going on 5 years now, and it looks something like this. We had one file that was over 7,500 lines long, just in one JavaScript file, and we had about 15 of them. So this was a problem. It's hard to work in something like this. So here's some concrete numbers. We didn't actually have static analysis on our project. I added that later, and I'm going to talk about that in a little bit. But when I ran the static analysis, we ended up with over 18,000 warnings on our existing code base and 284 errors. Now, most of those warnings were like typos and code formatting and stuff, but still, pretty bad. We had a 291-line function. In one function, 291 lines long. We had a function that took 55 input parameters. That's ridiculous. And I'm going to go over that one actually in a little bit. And our average file length, the average was 851 lines long. The maximum, 7,683 lines. And perhaps worst of all, we had no code coverage. We had no testing at all in JavaScript. So what was the answer? Angular. Let's use Angular. That'll solve all of our problems. So, we took our application. Here's what we had. Let's put it in Angular. And ta-da, it's in Angular now. So now we have an Angular application, but what did that get us? Absolutely nothing. So what did it teach us? That new tech does not give us what we need. It does not give us cost savings, does not give us faster time to production, and it doesn't give us a happy team. So what does give us those things? Cleaner code. So Before we talk about cleaner code, though, there are 3 things you need to address to write cleaner code. And before we get to that, we need to talk about the team that's going to be writing this code. Now, you may consider yourself to be a rock star or a ninja or whatever ridiculous term recruiters are using nowadays to talk about developers. But on projects I've been a part of, I found that the team is usually a pretty diverse group in either technical proficiency or experience. And the people who are writing the JavaScript may not have a whole lot of experience in JavaScript. They could be back-end programmers who aren't really happy that they're in JavaScript because it's not real programming. Or they could be fresh out of college hires like we just talked about, who their only experience with JavaScript may be a class they took 3 years ago, their freshman year, that they may have slept through a couple times. So because of this, we have a wide range of technical ability on the project. So to make a productive team like this, we need to set some baselines. So how do we set a common baseline on our project? We use coding standards. So first, coding standards can cover any situation you might encounter, from styling to naming conventions to what framework you use, whatever. So if there's one thing developers love to do, it's argue. We love to argue over coding choices. We like to do tabs versus spaces, Vim versus Emacs, Mac versus PC. Doesn't matter. We're going to argue about it. So by setting coding standards, you can prevent these arguments. And also, you can prevent making the same mistakes that you made before. So if you want to set coding standards, where do you get started? You need a common place to start from. Well, you can always check out community guidelines. So here's 3 popular ones for JavaScript. So Airbnb has a great just general JavaScript guidelines. Google has actually produced one for the Angular core team. And this guy is John Papa. He's produced probably the most popular Angular style guide. You can use any of these or a combination of them and just work them around until you get something that your team can agree on. So on my project, we took that and we came up with some rules. These are just a few of them, but we addressed these issues that we had before. So our static analysis, we didn't want any warnings or errors. Our max function length, we said 291 lines is ridiculous. So let's cap that at 50. No one wants 55 input parameters, so let's max that out at 10, which I think is still high, but we'll work with that for now. And the average file length, we didn't think we needed a rule yet. We figured some of these other things might work itself out. And our code coverage has to be at least 80%, at a minimum. So, now we've set some rules. Well, that's great. Everybody's just going to follow the rules, right? That's what happens. Of course not. So now we need to set up so that everyone is accountable. We need accountability to the rules. So the way we did it on my project is first we set up, there's 2 ways that we set up accountability. First, we set up an automated build pipeline that enforces a lot of this for us. And the second I'll get to in a second. So first we started with a gulp build process. And then we added JSHint. This checks for code quality. Then we added JSCS for style checking. Then we package everything up. We run it through Karma and Istanbul. These are testing and code coverage. And then we deploy it out for each developer. No big deal, but it was just a simple build process, but it enabled us to use these tools to enforce the standards that we had already set. And then secondly, we set up code reviews. And then in these code reviews, the main thing that we did was we talked about some of the rules that we had set up. So first, there are some things that you can't cover in an automated process. First, we needed a way to talk about naming conventions or just how we want to use the framework. Secondly, we could do knowledge sharing. Like this guy's, teaching these other people what they're doing, or what he's doing. We can get really heads down on a project, and so by doing code reviews, you can explain to each other what you're doing on a project, so everyone will have an idea of the bigger picture. And then finally, you can cover the unknown unknowns. These are the things you didn't know you needed rules for before you began. And I can go over a situation that we had on our project that covers that very situation. So we had a simple function that searches for something. Doesn't matter what, just some sort of product. First, we brought in some search text. Then we added some fields for sorting, some fields for pagination, some fields for filtering the dates. We're fine here, right? But now we want to sort on some other fields, and then a whole bunch more. And it became 55 input parameters. This is the function that was 55 input parameters with the words changed. So this became a real problem in the code review. We didn't really know we needed to enforce something like this because it seemed straightforward. But I noticed that whenever this was getting called, it ended up looking something like this, a whole lot. We got a whole lot of repeating Booleans here and 4 different nulls in a row. Like, it didn't make a whole lot of sense. Like, For instance, if I want to set the max price variable of this, anybody know which one of those nulls I want to change to be the max price? It's that one, that one. I don't know, am I supposed to count this out every time? So it seemed pretty ridiculous. So what we agreed on was that we would limit this down and use an object. So you pass in the search text, you pass in the max price, everything else is optional. We don't need all these input parameters. We just pass in one object with a bunch of different options that you could put into it. And that worked for us. And so once we figured that out, then we set a rule that you can only pass in a maximum of 10 parameters. And that works for us now. So now that we've got our coding standards and we've held each other accountable for that, the next thing we need to come up with is the technology. Now we finally can choose technology that will help us get cleaner legacy code. So how do we do that? Well, let's just use Angular, right? Or we could use any of these other alternatives. They're all perfectly fine, but that's a different tech talk, so I'm not going to cover that. We're just going to do Angular. So how do you write Angular? Well, you don't do this, first of all, like we talked about earlier. So let's go over some, the important thing is that you don't write Angular like it's jQuery or like it's something else. You work within the framework and do things the Angular way. Let's take this example. So we have a simple HTML form here. It's a first name and last name. When you click the button, it says hello to the user. In jQuery, you would have to look up from the DOM each time and get the values from there. So the DOM is the source of your model, which is slow and error prone. So Angular introduced data binding. The data binding allows you to automatically bind things from the front end to the back end being the JavaScript code in this case. So we take our previous example and we have something like this. Looks very similar on the front end. Instead of IDs, now we have ng models and ng clicks instead of on clicks. But whenever you click that, you don't have to look it up anymore. This is bound directly to first name and to last name. Much faster, much less boilerplate. Makes for very happy developers. So the next thing we need to talk about is services. So in our jQuery app, we had something like this. So we wanted to get the user. We have a lot of AJAX queries to do that. Or we want to create a new user. We have another AJAX query to do that. We want to update a user. We have another AJAX query. These were just all over the place. AJAX queries everywhere. So Angular created services. And services are wrapper objects that enable you to encapsulate communication to third-party services or something like that in a common place. So we take our current example in jQuery. And in Angular, we create a service. We just have a user service. We add our functions that do that. It uses Angular's HTTP service, but doesn't matter. Because in our controller, we don't need to know that. We just call getUser, and it does it for you. So, you may say that's pretty similar to the jQuery side, but what if I want to change out, instead of using a REST API, I want to use WebSockets now? Well, in jQuery, you'd have to grep through the file and find that. And you'd have to update everywhere you call that to use that. In Angular, I just change out HTTP to be WebSockets. This doesn't change. Controller doesn't change at all. Doesn't need to change, doesn't need to care. Just now we're using WebSockets. That's why you would use something like services to hide that. So now let's talk about the next thing in Angular, which is global variables. So in our application, that 7,000 line long file, or 7,000 line file was filled with global variables. We used them everywhere. We had something like a base URL and a user object that was empty whenever we first started. And then whenever we load up the first page, it loaded up our user object from a REST API. Then on some other page, maybe we wanted to show the user's name in some name box. No problem. But this was all over the place, and there were global variables everywhere. Well, Angular, so you can see the global variables here. So Angular introduced dependency injection. Now, dependency injection allows you to use Angular modules, and then modules are like Java packages for the Java developers in the room. It allows you to inject those into other packages so that you can use the values within. So let's take what we had before. We create an Angular module with a constant that says, here's my base URL. And so if I create another module and I depend on it up here, I have a user module and I depend on the second module inside the first module. So now I can do a lookup to that config object and get the base URL inside of my service without having it look up to a global variable. Or I can create a controller on my first module that uses the service in the second module. And by doing that, I can call the functions that were on this service without using global variables anywhere and nicely encapsulating everything. And finally, the last concept that we used in Angular was image templates. So we have a gallery here. And so in this gallery, we have 3 images. So we can just hard code these images in, no problem, right? But that's not very scalable. So we want to do it in JavaScript. So we take those out and we create an image thing and we loop through it. But now we have some HTML in our JavaScript. That's not good. Now we've got HTML and JavaScript all mixed together. And that's a maintenance nightmare. We had this all over the place in our application. So Angular has something for that called components or directives. They've changed the name a couple times. So to use Angular components, first you'd create a directive for the gallery. And then we give it a template and we pass in an images object. Pretty straightforward. So then that template looks like this, that just repeats through all the images that get passed in, takes the image, that's the URL and the alt text for it, and outputs an image. It's all written in HTML, and then if we want to call it in another piece of HTML, we just add gallery images equals some images that are bound to a controller somewhere. Pretty straightforward. And everything is all nice and clean. There's HTML in the HTML and JavaScript in the JavaScript. So now that we've got all that, we've used our technology correctly. So we've gone from something that looked like this, very powerful app. This is where we started. It was a very powerful app, but very hard to maintain. And we had this, if you remember. We had all these warnings, all these really bad problems. And then we went to adding rules. And we added a build pipeline to enforce those standards, as well as starting code reviews, which enabled us to get to this. In our Angular application now, we have no warnings, no errors. We have less than 50 lines per file, like we said, 10 input parameters, not the ridiculous 55 we had before. Our average file length, which we didn't even have a rule for, is now gone down to 53, which is pretty good. And our code coverage is 87%, with the vast majority of the app being at 100%. So what does that give us? This is all nice. We have very nice clean code now, but what does that mean for the business owner? Well, we've had less hotfixes than we've ever had before. In our old app, we had 10 plus, over 10 hotfixes. In our Angular app, we haven't had a single one so far to address an Angular issue. Now that may change in the future, but given all the rules that we've set in place, this enables us to produce cleaner code and not have any issues get into production. So that's allowed us to go from this that we had before to a more maintainable application, which enabled us to do the things that the cleaner code gave us, enabled us to reduce the cost of maintenance and to produce stable, cleaner code faster and to have happier developers, because who'd rather work on this than the other issue? So here's the resources I talked about before, the style guides. We're also currently writing a blog series on the BTI blog. And questions? Yes?
How has it affected the performance of the app?
Performance has been about the same. A lot of the performance in our applications is bound by the back end. So the front end is negligible one way or the other. Yeah?
Talk a little bit about how receptive your team was, especially the ones that were part of the legacy.
Yeah, so the team realized there was a problem, so they needed to do something. They needed to use Angular. They had decided that, but even before I got there. The coding standards and setting the rules, there was some pushback on that, and that's where the code reviews really come in handy, because we can discuss these rules before we put them in place, and then it's a living document, so we can keep discussing them as we go. And so like the one developer that had the 55 argument method wasn't really happy that I called him out in a code review, but over time we've all kind of come to agree that those are the rules, and if we follow them, we get some noticeable improvements.
What sort of things did you do to hold each other accountable?
Mainly the code reviews and then the automated builds. With the automated build, you get a nice big warning if you do something wrong, which is nice. You either fail a test or you have a JS hint warning gets thrown out. So with those issues just right in your face before you can even check the code in, each developer can see, hey, I've got an issue. And then at the code reviews, if you do put something in that has an issue, we can hold each other accountable for that. Yeah.
Did the average file length include test files, or is that just?
No, that was just source files. Yeah. Yeah, the tests are usually a little longer, but yeah.
Did you guys have any method to your madness on getting your test coverage up from when you started?
Mainly just write tests. That was the important part. Just actually start writing some tests, because we went from 0% before, so it wasn't hard to get better than that. But to get us up to over 80%, we had to just keep at it, just keep writing tests and ensure that you had that in there. Yeah.
Did you guys start just writing tests
each time, or take like a whole?
Yeah, so the way we did it is we have two apps basically running side by side, the legacy app and then the new application. As we port over features little by little, and as we write those new features in the Angular side, we write tests for them. Yeah.
How did you get your customer to buy off on the time it would take to do a massive rewrite like this?
A lot of that was before I got there, but that they'd made this decision. But I think they realized that because of all these bugs and all the issues that they had seen, that something needed to change. And so, yeah, it takes a little longer up front to transition everything over to Angular, but we're producing cleaner, more stable code that doesn't require ongoing maintenance like the old legacy app did. Yeah.
Do you guys have manual testers?
No, we don't. No. I mean, if we do, it's the developers. We test each other's code, and not very well. So, I see Ron smiling back there.
So
But yeah.
I guess I'm assuming that now that you have injected unit testing into the process, you've seen the amount of defects.
Go way down. Yeah. Yeah, and we have unit testing and end-to-end testing. A lot more. The 87% was unit testing. End-to-end testing is a lot lower, given some issues in the environment we work in. But yeah, it's made it so that we don't need as much manual testing each time, especially the regression testing. You can be ensured that what changes you made this time didn't break something you did last time. Yeah. All right, cool. Thanks, guys.
Thanks, guys.